In order to highlight the importance of planetary defense, scientists have described what would occur if an asteroid were to strike Earth. The fictitious asteroid scenario shows how an asteroid danger might develop over time and the possible destruction a hit could bring about. On January 10, 2023, a new asteroid was discovered and given the name 2023 PDC. The object is initially classified as a potentially hazardous asteroid PHA, which NASA defines as any asteroid that intersects Earth's orbit at a distance from the planet of about 4.6 million miles, 7.4 million kilometers or less, and that has a magnitude of 22.0 at the time of discovery, which is only slightly brighter than the faintest stars visible to the Hubble Space Telescope. The impact chance of 2023 PDC is initially only 1 in 10,000. However, experts noted that as asteroid tracking technologies on Earth continue to follow the rock, better restricting its orbit around the Sun, this probability slowly grows. At a point called Epoch 1 by experts, the situation becomes serious on April 3, 2023, according to Paul Choders of NASA's Near-Earth Object NEO Program Office. Today is Epoch 1, and the impact probability has now reached 1%. The potential impact won't happen for another 13 years, so it isn't urgent. However, we can already estimate when it might. The NEO program manager emphasizes that crucial decisions need to be made now despite the potential effect date being estimated to be October 22, 2036, which gives more than a decade for preparedness. The way mankind responds to the threat will depend on a number of unresolved issues, some of which are characteristics of the 2023 PDC asteroid itself. Better asteroid size calculations will be one of the first things astronomers accomplish with their 13-year lead time. According to NASA, this is accomplished by measuring the quantity of light that the asteroid reflects back into space, or its albedo. Therefore, the larger the asteroid is in theory, the more light it reflects. The challenge with this measurement is that the albedo is also influenced by how reflective the asteroid's surface is. The implication is that a small, light-colored asteroid may have a higher albedo than a larger, darker one. As a result, there may be a lot of uncertainty regarding an asteroid's size. The size of 2023 PDC is estimated to be between 720 and 2,200 feet to 20 to 660 meters. However, if the asteroid's surface is black, it might be as wide as 1.3 miles, 2 kilometers. The size of the asteroid is crucial since it will decide not only how much damage it causes, but also what steps must be made to divert it or even whether this is even possible. According to Choders, nuclear is truly a key approach on the table when you have a gigantic object, even as large as 2 kilometers, 1.2 miles, and there's a very, very little possibility of that. It follows that kinetic impactors, such as those used in NASA's Double Asteroid Redirection Test, would not be a viable choice for diverting a huge asteroid that is headed for Earth. Infrared astronomy cannot be used to measure the size of 2023 PDC because it is too close to the Sun. Otherwise, the light from the object would be washed out by the Sun's intense brightness. According to Choders, space-based telescopes like the James Webb Space Telescope JWST and the Hubble Space Telescope, which mostly rely on infrared observations, won't be much assistance in observing this rock. Similarly, the asteroid won't be close enough for radar to detect it in the early stages of its approach. That implies, according to Choders, that our earliest options for estimating the asteroid's size are optical observations. As a result, astronomers are unable to gather as much information as they might like about 2023 PDC, information that would help them to further constrain the asteroid's size and orbit. A reconnaissance spacecraft might be sent to 2023 PDC as one possibility for decision-makers to consider during the 13-year lead time. In addition to allowing us to more accurately determine the asteroid's size and mass, this would also allow us to better constrain one of the asteroid's most important characteristics, which is its orbit. which is essential for reducing the impact it will have on Earth. 2023 PDC is too far away from Earth at the time of its detection in this hypothetical scenario, about 124 million miles, 200 million kilometers away, to determine its orbit. The asteroid will likely catch up to Earth over the next 13 years, and the two may collide in a small red box, which represents the intersection of Earth's orbit and the 2023 PDC. According to Chodas, despite being far away and faint, the asteroid has an orbital period that is very similar to that of Earth and is even slightly shorter. There is a lot of uncertainty about where the asteroid will be in 13 years. But as we track the asteroid, that uncertainty will get smaller until it is actually smaller than Earth. The red hit box in the team's calculation was shrunk to a size smaller than the size of the Earth, indicating that the 2023 PDC will indeed strike the planet. The precise location on Earth where the asteroid will make contact with the planet can then be predicted by astronomers. So, what can we expect? Lorian Wheeler, a NASA advanced supercomputing expert, noted that assessing the potential harm of the 2023 PDC entails developing an asteroid impact risk assessment model and taking into account numerous variables, such as the asteroid's size and other features. From sparse observational data, local ground damage caused by an explosive burst or fireball is one of the three basic types of impact hazards that Wheeler and his team model. In addition to the possibility of tsunamis having significant oceanic consequences, there is also the possibility of global climatic implications in the most extreme scenarios. We model all of these cases and then combine the results to look at the probabilities of different damage sizes and damage severities, how many people that damage could affect, and what regions could potentially be at risk. The lower size estimate for the 2023 PDC is roughly 1,000 feet 300 meters in diameter, which would cause destruction on the scale of an entire continent and emit up to 2,000 megatons of energy. That is equal to 133,000 times the energy that is thought to have been released by the bomb that destroyed Hiroshima at the end of World War II. The possible catastrophe that 2023 PDC's influence could cause becomes considerably as its size increases. With a diameter of 2,000 feet 600 meters, the impact would be on the verge of a global catastrophe. This massive hit from 2023 PDC would produce up to 20,000 megatons of energy. Hence, doubling in size has resulted in an increase in destruction power of about 10 times. The 2023 PDC impact scenario gets extremely bleak at 3,330 feet 1 kilometers wide. The team determines that 2023 PDC is considerably more likely to result in a global catastrophe at this size. About 100,000 megatons of energy, or 6.6 million Hiroshima nuclear explosions, would be released in such an impact. According to Wheeler, there are other elements besides size that affect the spectrum of possible impact energy and, consequently, the severity of the subsequent damage. One such aspect is the asteroid's angle of entry into the atmosphere. The most dangerous scenario, according to Wheeler, is one in which there is a significant ground impact or a low airburst that produces a fireball and blast wave that are extremely destructive. Given the size of the objects we have here, the damage severity is expected to reach unsurvivable levels, with larger areas of damage extending to areas around it, experiencing fires, structural damage, and extending out to areas of shattered windows, the report stated. Wheeler proceeded by saying that for smaller impacts, outside damage areas are a band that may have a diameter of between 62 miles and 124 miles, 100 to 200 kilometers outside the main impact zone. If the fictitious asteroid approaches a size of 2,000 feet 600 meters, this enlarged damage zone might have a circumference of up to 372 miles 600 kilometers. In the hundreds of thousands to millions, Wheeler added, there is a potentially high number of people that could be affected all along the swath. Impacts over land cause the most population damage, with averages between 10,000 and 10 million people depending on the location. And if the impact is on the larger size, those ranges could go up to tens of millions to the hundreds of millions range, according to the report. She went on to say that if the asteroid 2023 PDC impacted any ocean, it would cause a tsunami, but that the Atlantic Ocean would be the location where it would cause the most devastation to people, since it would be the most likely to cause a tsunami that would be able to affect populous regions. Millions to billions of people worldwide could potentially be impacted by the long-term climate change implications of a larger asteroid strike of the 2023 PDC. Hence, there is a very wide range of potential damage. Wheeler said in the end, the potential repercussions are so severe that if it hits Earth, it might be exceedingly harmful. Are we prepared? Please subscribe to Weather Collapse if you want to know more and be updated on the latest news about natural calamities or disasters happening all over the world. And don't forget to like today's video. We'll see you in the next video. Thanks for watching.